Hello there. Welcome to the T-Test with SPSS walkthrough. My name is Max Santamaro. Whether you're new to stats or just starting with SPSS, you're in the right place. Today we're answering a practical question. Do customers who left the bank in Europe have a different account balance than those who stayed? We'll be using a real-world data set from a file called BankTrend, which is available on the Maven Analytic website. The key variables we'll be focusing on in this data set are exited, whether a customer churned or stayed, and balance, the customer's account balance in euros. You'll see exactly how to run an independent samples t-test, step by step. Don't worry if SPSS looks a bit intimidating, I'll guide you through it slowly and clearly. So let's open up SPSS and get started. Now, as you can see here, I have my data imported already, but if you haven't done so, you can always go up to here, File, Import Data, go down to CSV Data, since that's the file that we downloaded. If you haven't done so already, you want to make sure you do that. Navigate it where you downloaded it and just open it. Or if you already have it imported, you can just go to Open and click Data, and you'll be able to find it that way. Now, one thing you want to keep in mind is to always make sure to verify your data before you even start anything. So as you can see here, you have your rows, and then you have your columns where you actually have your variable names. And one thing to take notice of that what we actually want to focus on is our balance variable, which is in this column, and our exit variable, which is in this column. You want to pay close attention as to what these columns represent. For example, you have this balance variable right here. This is the amount in the customer's account, which is in euros, which is what we're going to be working with. And then you have this column for exited, which pretty much tells us whether the customers churned, which means left, or they stayed. And from here on, we want to check these variables. We want to confirm that these variables are correctly set up in SPSS. So what we're going to have to do is we're going to have to go over here to the variable view. Just click on there. Now, as you can see here, I have both the balance and exited variables highlighted. And one thing to pay attention to is their measurements, how they're set up in their measurements. So for balance, you want to make sure it's set up on scale. This indicates that it's a continuous variable. It's all numerical. And that's pretty much how it's set up here in the balance. They're all numerical values. And then for exited, you want to make sure it's set up as nominal. You want to set it up like that because it is pretty much the values you're dealing with here are categorically ranked. Like, for example, if you have two values for 0 and 1 for gender, where 0 is male and 1 is for female, you want to set it up like that. You're not working with a lot of numerical data. And in this case, you want to set it up with people that have stayed or they turned out or left. So once you make sure that's how they're set up, we want to go back to data view. Now that we're back in our data view, let's go ahead and take a moment to ensure everything looks right. Are both groups represented? Do the columns match what you expect? If everything looks good, let's go ahead and just move on. Now let's take it a step further and get a quick summary of the data to check for any obvious issues. And one way we can do that is by using descriptive statistics. So what we're going to have to do is come up here to Analyze, pick Descriptive Statistics, Descriptives. So as you can see here, this will give you a quick overview of the average balance, standard deviation, minimum and maximum values for the balance column, and also for the same thing for the exit value. It's a great way to catch any outliers or data entry errors. For example, if there are absurdly high or low values, then this might indicate a problem with the data entry. Once you see the results, notice the mean for each group. The mean balance for the group that stayed and the group that churned can give you a sense of whether there are any obvious differences before we dive into the t-test. Now, just to confirm, we're using balance column as our test variable, and the exit column will be our group variable, which is divided into two groups: churned, which means they left or stayed, as you can see here, zeros and ones. Now that we have a quick sense of our data and have checked for any glaring issues, we're ready to move on to formulating the hypothesis. Now that our data is ready, the next step is something every good analyst starts with: formulating hypothesis. This is where we clearly state that we are trying to test and give structure to the whole process. In our case, we're asking, do customers who left the bank have a different account balance than those who stayed? To answer that, we'll compare the mean balance between the two groups: customers who churned and customers who didn't. Here's how we break it down. For the null hypothesis, we're determining that there is no difference in mean balance between the two groups. Alternative hypothesis is there is a difference in mean balances between the two groups. Basically, the null says, hey, any difference you're seeing is just random noise. The alternative says, nope. There's a real statistically meaningful difference between these two groups. And just to clarify, exited is our grouping variable that tells us who churned and who stayed, and balance is our test variable. It's what we're comparing between the groups. With our hypothesis locked in, we can now choose the correct type of t-test to help us evaluate them. Okay, we cleaned up our data set, double-checked the variables, and written our hypothesis. Now we reach a critical decision point. Which t-test should we run? In SPSS, there are a few types of t-tests, but the two most commonly used are the independent samples t-test and the paired samples t-test. And the choices really boils down to one key question: are your two groups made up of the same people or different people? Let's break them down. When it comes to the independent samples t-test, this is what we use when we're comparing two separate groups of people. Think of it like two different buckets: one group that stayed with the bank and one group that left. Each person is only in one group, not both. In our data set, that's exactly what we have. Each customer appears only once, and they're either marked as having exited the bank or not. That makes the groups independent of each other. So the independent sample t-test is our best fit here. The paired sample t-test, now this one is used when you're comparing the same people at two different times. Like if you measure someone's balance between a major change and then again after. It's used when data points are linked or paired. Think of it like a before and after scenario. Say customer satisfaction ratings before and after a service improvement. Since it's the same person in both measurements, the samples are paired. So again, our case doesn't fit that structure. We aren't measuring the same person. Twice, we're comparing two distinct groups: customers who left versus customers who stayed. Here's an easy way to remember. If you've got two unrelated groups, use independent sample t-tests. If you've got the same group measured twice, use paired sample t-tests. Now that we've made up our choice, I'll walk you through exactly how to set up and run that test in SPSS. Let's dive in. Okay, on the top menu in SPSS, go to Analyze, Compare Means and Proportions, and we're going to be picking independent samples t-tests. And this tells SPSS, hey, I got two separate groups, and I want to compare their averages to something important. In our case, their account balance. So go ahead and click on it. All right, now we're getting to the really exciting part: actually running the independent samples t-test in SPSS. This is where we get to crunch the numbers and see if there really is a statistically meaningful difference between customers who stayed and those who left the bank. So first off, we want to go up here to Analyze, go down to Compare Means and Proportions, and we're going to be clicking on Independent Samples t-test. This tells SPS, SPSS, hey, I got two separate groups. I want to compare their averages on something important. In our case, their account balance. So go ahead and click on it. So then you see a window pop up. You'll see two boxes. First, move balance into the labeled test variables. That's what we're measuring. So we want to go ahead and do that here. Next, we want to get exited and move it into the group variable box. This tells SPSS how to split the data into two groups: those who stayed, which will be 0, and those who left. So you want to go ahead and drag it out over here, or just click right here when you do it. And then what you want to do is you want to click Define Groups, which is the small box right here. So within this small box, we want to go ahead and replace Group 1 with 0, and then Group 2 with 1. This is just telling SPSS use 0, which will equal stayed, and 1, which will equal churned. Simple as that. So once you do that, go ahead and hit continue. And we're going to go ahead and click OK. When we click OK, it'll open up an output window with our results. So click OK. And the SPSS will run the test and generate the output for us. So here, let's go ahead and first take a look at the group statistics table. This table will provide us with the average account balance for each group, as well as some additional helpful statistics. So here's what you'll see in the table. Here you'll see people that have either stayed for 0 or have churned, left. The number that have stayed, the number that have left, the means for both of them, the standard deviation for both of them, and the standard error mean for both of them. So let's go ahead and get a better understanding of what all these mean. So for the mean balance, the average account balance for the customers who stayed is $72,745, while the average balance for those who left is $91,108. That's a difference of about $18,000. When it comes to the standard deviation, this shows us how spread out the values are around the average. For the customers who stayed, the balances are more spread out. There are some customers with very low balances and others with higher balances, making the standard deviation larger. For the customers who left, there's some spread, but it's not as widespread as the stayed group. When it comes to the standard error mean, or SCM for short, this is a measure of how accurate our estimate of the average balance is. A small SCM means our mean balance is a more reliable estimate. Both groups have relatively small SCMs, meaning the means we're looking at are pretty accurate. So let's go ahead and take a look at the second table. This is the heart of our test. The independent sample test table tells us if the difference in account balances between the two groups is statistically significant. As you can see here, we have what they call the Levin's test for equality of variance. The Levin's test tells us whether the variability or the spread of the account balances is similar across both groups. In this case, the F value is 193.160, and the significance value, or the P value, which is a very important value in statistics, is less than 0.001. This suggests that the variances are unequal between the two groups. This is important because it tells us not to assume the variances are the same, which will affect how we interpret the results. So what do we do with this information? Since the variances are unequal, we'll focus on the row labeled equal variances not assumed. This row gives us the more reliable results when variances are unequal. Now let's go ahead and break down the results of the next row, which is the t-test for equality of means. When it comes to this, the t-test value for this is negative 11.936. Usually you want it somewhere between negative 2 or positive 2 in order for it to be considered small, but in this case, it's extremely large. This means that the difference between the two groups is very large compared to the variability within each group. A large t-value indicates a stronger, more reliable difference between the groups. Now, when it comes to the degree of freedom, the degree of freedom refers to the amount of information used to calculate the test statistics. Here, we have 3,347 degrees of freedom. Actually, 3,348 degrees of freedom when you round up, which is plenty of data to support a valid test result. Now, when it comes to the significance, or what we call the p-value, this is less than 0.001, which is extremely small. A small p-value means the observed difference in account balance in the account balances between the two groups is almost certainly not due to random chance. In fact, it's very likely a real difference. All right, we've run the t-test, we've seen the tables, and we know there's a statistical significant difference in account balances between customers who stayed and those who exited. But let's not rush past the key statistics just because we saw a p-value that's less than 0.001 and a big t-value. These numbers actually tell a story, and understanding that story is what makes you a stronger analyst, not just someone who reads off a number. Let's start off with the t-value. The t-value, or statistics, is really at the heart of the whole process. It's a number SPSS calculates to compare the difference between the two group means relative to the variability within the data. Think of it like this. If the average balance for churn customers is $91,000 and for retained customers it's $72,000, that's a big gap of over $18,000. But we can't just stop there and assume it means something. Why? Because there's natural variation in every group. Imagine two overlapping hills. Each hill is a group. The t-value measures how far apart those hills are in comparison to how wide they are. If the hills are wide and low, they might overlap even if the top are far apart. If they're narrow and steep, even a small gap between the peaks could be meaningful. In our case, SPSS calculates the t-value of negative 11.936 or negative 12.47 when assuming unequal variances. That is a huge value because you got to remember, in order for it to be a small value, it has to be between negative 2 and positive 2. The negative sign means that group 2, the ones who left, which equals 1, had a higher mean than group 1, the ones who stayed, which equals 0. But what really matters is this huge value right here. A value that extreme tells us the difference between the groups isn't just some small blip. It's a very strong signal. So what influences the t-value? Let's unpack that. The numerator, mean 1 minus mean 2, is just the raw difference in means. In our case, that's 18,363 euros. The numerator, the standard error of difference, measures how much variation there is in those sample means. The smaller that error, the more confident we are that the observed difference isn't just noise. So if we have a big difference in means and small variation, you'll get a large t statistic. That's exactly what we have here. Let's add context from the t-test for equality of means section of the SPSS output. In the SPSS output table, the row labeled t-test for equality of means gives us several critical values all at once. So let's go ahead and walk through a few that matter the most. We're going to go ahead and focus on the equal variance not assumed, since this is where we have to be. And we have our mean difference of 18,000, 363. This is the actual difference in average balances between customers who exited and those who stayed. The negative sign tells us that those who exited had higher average balances. Then we had our standard error differences of $1,472. This tells us how precisely we estimated the mean difference. A smaller standard error means we can trust the result even more. In this case, the standard error is relatively small, which strengthens the reliability of our findings. Now let's move to the degree of freedom, or DF. I know this sounds like a complicated concept, but degree of freedom is just a fancy way of saying how much data do we have to work with. Think of it like this. If you're trying to estimate something, like the average balance of a population, the more data points you have, the more precise your estimate will be. Degree of freedom reflects how many pieces of independent information are available to estimate the variability. In our test, we see two versions of DF. One for equal variances assumed at 9,998, and one for equal variances not assumed at 3,348. It's because when we assume equal variances, we pull the variances together and can use more of the data to estimate the standard error. But if the variances are unequal, and in our case, Levin's test told us they are, we assume more conservative approach. That's why the DF is lower. Bottom line, the more degrees of freedom you have, the more precise and trustworthy your t-test becomes. And with 3,348 degrees of freedom, that's a very solid amount. No red flags here. Finally, let's talk about the p-value, or the significance value. Yes, the famous or infamous p-value. Probably the most misunderstood number in statistics. So what is the p-value? It's not the probability that your hypothesis is true. It's not the chance that the results are wrong. Instead, here's a correct way to think about it. The p-value is a probability of seeing a result this extreme or even more extreme if the null hypothesis were actually true. In plain English, if there really were no difference between the groups, if customers who stayed and customers who left had the same average balance, then the difference of 18,000 euros would be incredibly unlikely. Here's a helpful analogy. Imagine flipping a coin 100 times. If it's there, you'd expect about 50 heads. But what if you got 92 heads? You probably think something's off, right? That's because the likelihood of that happening with a fair coin is incredibly small. That's what a low p-value tells us. That's why we reject the null hypothesis. It's just too unlikely that this result happened by chance. So instead, we accept that the difference is probably real, or what we call the alternative hypothesis. Quick note, when it comes to one-sided versus two-sided p-values in SPSS, you'll see both a one-sided p and two-sided p-value. These aren't just different numbers. They reflect different types of questions. A two-sided p-value tests whether there is any difference, either higher or lower. It's a default for most analysis. In our case, we asked, is there a difference in account balances? Without saying whether exited customers would have more or less. That's a two-sided test. A one-sided p-value test is used when you predict the direction of the effect ahead of time. For example, exited customers will have higher balances. In that case, we only test for the result in one direction. In our output, both values are reported as being less than 0.001, which tells us that even in a more conservative two-sided test, the difference is highly significant. If you're even unsure which one to use, go with a two-sided p-test. It's safer unless you have a very specific directional hypothesis ahead of time. One more thing. Let's explain the 95% confidence interval of the difference. The last piece of SPSS output we haven't really discussed is a 95% confidence interval. For our test, the interval is from negative 21,250 euros to 15,476 euros. This interval means we are 95% confident that the true difference in account balances between those who existed and those who stayed is somewhere between these two numbers. And because this range does not include zero, it reinforces that the difference is statistically significant. Confidence intervals are helpful because they give us not just a single number, but a range of likely values. So instead of saying the difference is exactly 18,363, we say it's probably between these two amounts. That gives a more realistic and informative picture. All right, let's make all this real with the story. Stats are powerful, but they don't have to be dry. Imagine this. You've got two friends, Alex and Jamie. They both go to the gym regularly, and you're trying to figure out who's actually stronger. But you don't just want to eyeball it on one day. You want to really know. The T value is like the difference in their lifts. Say Alex benches 225 pounds today, and Jamie did 205 pounds. That's a 20-pound difference. But does it mean Alex is always stronger? Not necessarily. Maybe Jamie was tired, or maybe they usually lift the same and this is just a fluke. The T value helps us figure out, is this 20-pound gap big enough to matter compared to how much their daily lifts usually fluctuate? So if the T value is big, like in our SPSS test where it's negative 12.47, that's like saying Alex consistently lifts way more than Jamie. It's not a one-time thing. It's a real meaningful difference compared to their usual variation. Now, when it comes to the degree of freedom, or DF, that's about how much data we've got. Think of it like this. If you've only seen Alex and Jamie lift once, you're guessing. But if you're tracking their workout for 6 months, that's evidence. That's your degree of freedom. In our bank test, the degree of freedom was over 3,300. That's like saying we've got data from thousands of gym sessions. We're not guessing, we're making a conclusion based on a lot of observations. Next up, the p value. Let's go back to the gym. Imagine this. Every time you watch them, Alex lifts more than Jamie. Not just once, but every single time. After a while, you start thinking, okay, this probably isn't just a coincidence. That's what a low p value tells us. In our test, it was less than 0.001. That's like saying there's less than a 0.1% chance this difference happened by luck. So we feel really confident saying this isn't random, there is something going on here. And finally, the confidence interval. Let's say you estimate that Alex lifts about 20 pounds more than Jamie on average, but you don't just want a single number, you want a range. So you say, I'm 95% sure the real difference in strength is between 15 and 25 pounds. That's your confidence interval. It's like saying, based on everything I've seen, I'm pretty sure the gap is in this range and not zero. In our SPSS output, the interval was between 15,476 euros to 21,250 euros. And because zero isn't anywhere in that range, it confirms that the difference is real. So let's tie it all together. When it comes to the t value, this tells us how big is the difference compared to the noise. Degree of freedom, this tells us how much data are we working with. P value, could this result just be a fluke? Confidence interval, how big is the difference given a range? So when you see all four of those stats lining up, like in our test, it's not just numbers. It's a real strong evidence-based answer to our question. And that's how you use stats, not just to analyze data, but to tell a story you can trust. Thank you for taking the time to watch this video. My name is Max Santamauro. Goodbye.